So we're finishing number 16, 7 to 21, 21 to 63. So it's not the same as adding 14 every time because the numbers are different. So if we times by 3, that will work until we get to 63. If I times that by 3, I do get 189. So on this one, it is times 3 every time, and it works throughout the whole thing. So this is exponential. And the last one, 2 to 8, I could add 6. If I add 6 again, I would get 14. So adding is not working out. If I do 2 times 4 to get 8, 8 times 4 is 32, and 32 times 4 is 128. So this is multiplying by 4 every time. And so that is exponential also. Okay, we determined whether they are exponential or linear. Which function grows the fastest? So fastest growing, we know that exponentials grow the fastest. So it's either going to be the second one or the third one. And because this is multiplying by 4, whereas this one's multiplying by 3, the one that's growing the fastest has to be the very last one. So notice up here it's called h of x. So we could put the third table or we could put h of x because the other ones right here, this is called g and this one's called f. So they're different. And then it says write the explicit equation for each function. So table number 1. If I want the explicit, I could do a sub n equals, or I could put f of n. I'm going to call it what it's called in the table. Yeah, because the table calls it f of n. So I'm going to do that. F of n, right here, is the first term is 7. So the output is 7. We know it's adding 14. And then n minus, because we use the first term, we do have to minus 1. And the best way to write this out would be to simplify that. We could leave it. Simplifying is even better. So if I do 7 plus 14n minus 14 times negative 1 is minus 14. And then if I combine these two, I would have 14n. And 7 minus 14 is negative 7. So that would be the best way to write number 1, the table. The next one, gn, I'm going to put it here. Gn is exponential. So I'm going to use the first term again. So we got 7. It's timesing by 3 every time. And it's exponential, so I need an exponent, n. And I use the first term, so minus 1. There's not a lot of simplifying to do there, so I'm going to leave it. And the last one I've got is h of x. I'm going to put that over here, even though, yeah, they all are supposed to go in that spot there. So the explicit equation, hx, equals, the first term is 2. It's multiplying by 4 each time, and because we use the first term, it is exponential. I have the x as the exponent, and I use the first term, so I have to minus 1. So that's h. This is f, and here we got g. Okay, number 17 and 18. What is the rate of change of the function below? So our rate of change would be the rate at which the function comes from, right? It comes from principal 1 plus the rate to the power of t times to the exponent time. So it comes from our compound formula. So what we need to do here is we need to separate this out to find out what the rate is. So 1 plus To get 1.032, I would have to add 0.032. And then the R value, it's a decimal when originally it was a percent. So to change our decimal back into a percent, we multiply our number by 100. And if you do that, we get 3.2%. So it's an increase of 3.2% for the rate. What is the rate for this one on number 18? So again, we've got our principal, 1 plus, and then to the exponent p. This one's a little bit different because it's decreasing. If I do 1 plus, I need to add a number to get 0.89. So that's less than the number 1. So really, how much do I subtract to get the 0.89? So 1, I subtract 0.11. And you can try that out. Do 1 minus 0.11, you'll get 0.89. So we know that it's so here's our rate right here, 0.11. We times it by 100 to get back to a percent. So it's going to be the rate is 11%. But we are subtracting it. This is a decrease. It's 11% decrease. Whereas here it's a 3.2% increase. So the rate is 3.2, and on 18 it's a 11% decrease. Okay, number 19. Count the number of sticks. That means you're counting each and every one of these. So you got 1, 2, 3, 4, 5, 6 for the first one. The number of sticks. So input, output. On the first one you have 6 sticks. On the second one there's 3 more on the end, so that would be 9. And then again the third one there's 3 more after that, so there's 12. Create a table for the pattern. Okay, we did that. Graph the sequence. So I'm going to take the table numbers and graph them. We got 0, 3, 1, 6, and 2, 9. Oh, 0, 3. Yeah, we didn't really have that one, but there is a pattern, right? It's adding 3 every time. So if there were a 0, 1, you'd have 3 sticks in it. And then also the last one, 3, 12. So there's your graph. Write an equation for the number of sticks. So we could write this out. Could write it as the first term is 6. It's adding 3 every time. And then x minus 1 because I used the 6. And if we simplify that, 6 minus 3 gives us 3. So we'd end up with 3x plus 3. And if we want an equation, we better have an equal sign and let's just put a y there. Which you could have used the graph to figure that out, right? It's 3 over 1, 3 over 1. So your y-intercept is 3, and your slope is 3 over 1, which is what we have for our equation. Then it says, what is the 50th term of the sequence? That means I want to know if you have the 50th number, you plug in 50 into the equation, and we want to know the output. In this case, you would get 153 sticks for that 50th term. Given j of x and k of x, graph the system. So we know how to graph linear without making a table or doing a whole lot of work for that. So I'm going to start by doing that. K of x, which would be, if there's not a number here to start at, I start at 0, and I can go down 3 over 1, down 3 over 1, down 3 over 1, 3 over 1, 3, 1, 3, 1, 3, 1. So this is our solutions to the k of x. And then for the other one, we've got x. I'm going to make a table for this one, and j of x. And I need some negatives and I need some positives to plug in. I'm going to do -3. I'm going to put in a bunch of numbers actually, just to make sure I've got enough here. So those will work. If I plug in -3 into the x, so we would have 1/2 to the -3 minus 1. If we do that, we end up with an output of 7. Then we're going to change it to a 2. If we find the output there, we get a 3. -1 is 1. Plugging in 0, you get out 0. Plugging in 1, you get -1/2. Plug in 2, you get -3/4. And if you plug in 3, you get -7 over 8. And then we're going to graph it. So -3, 7, -2, 3, -1, 1, 0, 0, 1, -1/2, 2, -3/4, and 3, -7, 8. So we look like that. About. Something close to that. And it says graph and determine the solution. Well, they both have this point right here in common. And that is the point 0, 0. So that point is the solution to the system of equations, 0, 0. And that is it for our review.